Alright, today we're going to be talking about universal gravitation. Newton once said that any two bodies in the universe attract each other with a force that is proportional to the square root of the distance between them. Basically meaning that every mass is attracted to every other mass with a proportion on how far away they are from each other and also how big these masses are. So let me show you that in a picture. This mass is attracted to this mass with a force going towards each other. Mass 1 and mass 2. Now, the equation that goes with this problem, we have two, because we need to first find out what the force is, so it's F equals mass times acceleration, and also F1 equals F2 equals 1c. So those are the two equations you'll be using throughout this finding the universal gravitation of two masses. In our example problem, I'm going to read it out to you. What is the universal gravitational force between, in this case, X and Y, when a student, being X, with a mass of 70 kilograms is a meter away from a book, which is Y, that has a mass of 1 kilogram. So now we have some units for this diagram. This is a student, so it's 70 kilograms with a distance of 1 meter. And the book weighs 1 kilogram. For this equation, we can use this one easily. So we have G, which is a constant variable of gravity, and M1, which we can make 70 times 1, because the mass of the book is 1, over 1 squared. Okay. We can simplify that. We get 70 over 1 times G. And one thing I forgot to tell you is that G is actually equal to 6.67 times 10 to the negative 11th power. And its units, just so you know, are times m squared divided by kilograms. So then if you multiply 70 times G, you end up with if you multiply 70, which is what you get from multiplying 70 times 1 over 1 squared, and you multiply that times G, which is 6.67 times 10 to the negative 11th power, you end up with 4.669 times 10 to the negative 9th power, and that'll be your universal gravitation between these two masses. That'll be all. This lab can't be performed in class. It's more about concept and using the equations. Reason why is because you can't really measure in class you can't really measure the gravitational force between two things, because first off, some things aren't big enough to like have a visible or obvious gravitational force, just like the moon and the sun and Earth. So yeah.